Hi everyone, I'm going to present my final project. First, I'll introduce my data structure. I create a graph class which contains variable list and its corresponding conditionality list. And I also use an adjacent list and an adjacent matrix to do some graph operation. And the click set and potential tables are both stored into the clicks or further max clicks. These are the steps I do exact inference. First, I'll do mean field method to find the elimination order. In each time, it will find a variable whose unmarked neighbors can form a clique with minimal field edges. And then I'll follow the reverse elimination order. In each iteration, a variable will be selected, and I'll check that whether its neighbors can form a clique. If not, just adding some necessary edges to finish the triangulations. And then is to enumerate max cliques. Like the triangulation step, I follow the reverse elimination order. In each step, a variable will be chosen and it can form a max clique with its neighbors. With these max cliques, I can create a m by n weight matrix. This m means numbers of max cliques, and the weight is computed by the numbers of variables in the intersection between two max cliques. And then I can create a maximum spanning tree according to a weight matrix. To assign potential to max cliques for each potential function, it can only be assigned to a max clique if it's a subset of that max clique. That's why I put rate sign here to break up. To run the belief propagation, first I run for DFS to get passing order and put leaf clique in that order to the ready queue. Every time a clique will be taken out as a sender to send image, send message to its receiver. And calculate message is followed by a slice instruction. And once the receiver gets all its required message, it can be put into a ready queue to send the message. I compute log z by adding an empty node to the root of junction tree and marginalize over the variable in root. And finally pass the message to that empty node so I can get the z from that node. I choose loopy belief propagation to do approximate inference. First, I create an adjacent list to recall the linking relation to the factors, and the message list is used to store the message. I create a similar structure for both two directions. For variable to factor passing, blue part means the sending message which is the product of all messages comes from the related factors except the target factors. And for factor to variables, it is similar to before. In addition, the message needs to be marginalized over the target variable, which is shown in yellow square. A loopy belief propagation is running factor to variable and variable to factor iteratively until it is converged, which means the current message is sent as the previous message. To compute log z with approximation method, once I got the converged messages, I just follow the lecture notes to calculate the log z according to a better approximation to compute tau, entropy, and mutual information respectively.